carbon and its compounds. Carbon and its compounds. Related to this chemistry, we call organic chemistry. Organic chemistry, since most of these compounds are obtained from living things, plants and animals. The main constituent present in this compound is carbon. So it is also called, this chapter is also called carbon and its compounds. So first you keep side heading, subheading carbon. Carbon. So carbon has catenation property.
Hello. Yeah. Can you write that down, sir? I don't know. First time hearing that.
In here,
property to form long chains.
Ma? Chinmay, tell me.
Ability to form long chains.
Very good.
Allotropes.
Ability to form long chains, branched chains, and cyclic compounds. Cyclic compounds. First of, before going to catenation property, I wanted to explain carbon electronic configuration. Carbon atomic number 6, its electronic configuration is 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. 1s2, 2s2, 2p2. See students, here the second shell is the valence shell. It contains 4 valence electrons. 4 valence electrons. So to get octet configuration, it can gain 4 electrons, or simply we can say its valency is 4. Its valency is 4. It's equal to 4. So wherever carbon is there, it can form 4 bonds. 4 bonds. This is the Lewis dot representation. Carbon can form 4 bonds. Because of its tetravalency, it can form long chains, branched chains, and also cyclic compounds. Cyclic compound. That property is called catenation. Here, what is catenation property, students? Ability to form long chains. Ability to form long chains, branched chains, and also cyclic compounds. Cyclic compounds. This property is called catenation property. Catenation property. Next one. Carbon has some allotropic forms. Those are in this crystalline allotropes. Crystalline allotropes. Crystalline allotropes. In this, first one is diamond. In diamond, how carbon atoms are arranged, students?
Tetrahedron structure.
Carbon atoms are arranged in tetrahedral manner. Since here carbon is undergoing sp3 hybridization.
So what is allotrope?
Sorry,
What is allotrope?
allotrope is nothing but one element can available in different forms, like seed, diamond, graphite, colorings. All are different forms, but the main constituent is carbon only. Availability in different forms. Like phosphorus, if you take white phosphorus, red phosphorus, black phosphorus. Main constituent is phosphorus only. Availability in different forms. Allotropes. This you don't write it in properly. Just a tetrahedral manner. You had all these things in 9th standard.
Not very detailed.
No, these basics only. This. So here, no problem. I will explain once again. Carbon atom undergo sp3 hybridization in diamond. Basically, these questions they are asking upon that. Carbon atoms are arranged in tetrahedral manner, and carbon this here undergoes sp3 hybridization. So here, see students, here again this carbon connecting with 4 other carbon atoms. It's like a network structure. So diamond is very strong. This is also called network structure. Carbon atoms are arranged in network structure. So diamond is strong. Bond length between carbon atoms around 1.5 angstrom units. 1.54 angstrom units. And one more point related to diamond students. Here carbon has 4 valence electrons, right, students? Carbon has 4 valence electrons. Actually, it is not exact structure. I'm trying to do like this. We can't draw. These 4 valence electrons, I will keep only one basic unit. In carbon has 4 valence electrons. These 4 valence electrons involved in bond formation. So there is no free electron. Even in other carbon atoms also, in other case also, same thing happened. One carbon atom is connecting with the.
So it's an insulator.
Yes. So all 4 valence electrons are involving in bond formation. All 4 valence electrons are involving in bond formation. There is no free electron. So if free electrons are not there, compound acts as poor conductor. That is the reason diamond is poor conductor due to the absence of free electrons. To the absence of free electrons. So first point, what did I say, students? The diamond. First one is carbon atoms are arranged in tetrahedral manner. Tetrahedral. Second one is here carbon atom is undergoing sp3 hybridization. Third one is this it is acting as poor conductor due to the absence of free electrons. All the electrons are involved in bond formation. Because of this network structure, it is very hard. Okay. This is about diamond. Next one is graphite.
Sir, what is sp3? I didn't understand that.
Hybridizations, do you don't know? sp hybridization, sp2, sp3.
No, sir.
Chemical bonding. chapter did you get? I thought you know hybridization. If you don't know, leave it. Just write a point and leave it, because if I explain hybridization, 1 hour I need for hybridization. All the hybridization I have to cover. You just keep it. If I get time, I will explain. Dhruva. Actually, it comes in chemical bonding. I thought in 8th standard chemical bonding was there in foundation, so thought it is finished.
Yeah, that time you told sp3, but I thought that is a compound, sulfur and phosphorus.
No, that is hybridized. If just for timing, you just write. Later, if I get time, I will explain. Graphite. Graphite. In this, carbon atoms are arranged in hexagonal manner. Carbon atoms are arranged in hexagonal manner. So, and it's like layer structure. Layer structure. See here. This is one layer. In between the layer and one, these van der Waals forces of attractions will be there. Layer structure. Like this. Here, each carbon is connect these layers. One carbon atom is connecting with another 3 other carbon atoms. One carbon atom is connecting with 3 other carbon atoms. Once let me draw the structure, I will explain. Very badly it has some structure. Just only for understanding purpose, afterwards I will erase this one, students. So here, these are all hexagonal rings. If you consider this is one layer, this is one layer. In between this layer, some space will be there. These layers will be attracted by weak van der Waals forces of attractions. Van der Waals forces of attraction. There are physical attractive forces. These forces are very weak. All forces. So these two layers will get attracted to each other through van der Waals forces of attraction. That's why one layer will slide upon another layer. So graphite is used as lubricant for heavy machinery and all. It's used as a lubricant because of this layer structure. One layer is connecting with another layer. Emma, this diagram you don't draw. Has not come properly. I'll show at the end of the class. I got it is there in another file. I will open it and I'll show. This diagram you don't draw, just only for understanding purpose. And you just observe in this hexagonal ring. Stop writing, students. In this hexagonal rings, each carbon atom is connected with 3 other carbon atoms. 3 other carbon atoms means each carbon is forming 3 bonds. It's only 3 electrons are involving in bond formation.
3 electrons.
3 electrons are involved in bond formation. So out of 4 electrons, 3 only involved in bond formation, right? Other electrons, one electron, each carbon will get one free electron. Because of these free electrons, graphite acts as a good conductor. Generally, non-metals are poor conductors. Non-metals are poor conductors of heat and electricity. Only graphite conduct electricity because of these free electrons. Free electrons. Free electrons. Free electrons. So here carbon under what is the first point, students? Carbon atoms are arranged in hexagonal manner.
Layered structure.
It is having layered structure. Here carbon atom is undergoing sp2 hybridization. It acts as a good conductor. Good conductor due to the presence of free electrons. Free electrons. Next one, uses, if you see, used as a lubricant. Solid lubricant because of layered structure. Since it is having layered structure, one layer will slide on another structure. And it is used as, generally graphite used as electrodes, mainly acts as anode. Graphite is used as anode in electrolytic cells. This is about graphite story. Next one, fluorines.
Sir, is graphite burned to produce energy like coal and all?
So, graphite, Shravan,
Like, is it burned to give energy like how coal is used?
combustion of organic compounds gives energy. Gives energy. Since it is soft, less amount of energy only released. But in case of hydrocarbons, more amount of energy is released. So we can use those hydrocarbons as fuels. Buckminster fullerene, it is having football structure.
Hexagons and pentagons.
Yes. So it is arranged in pentagons and hexagons. Means 5-membered rings and 6-membered rings. How many 5-membered rings? How many 6-membered rings are there, students? In this? Well, 5-membered rings. I write 5 here, otherwise it will become 125. Six-membered rings. Example C60. Other polar rings are there, that is beyond your scope, not required. These are the allotropes of carbon. Actually, our intention is nomenclature, classification of organic compound that are to teach. But anyway, carbon and compounds I put heading now, somewhat properties related to carbon I have to give. So I am giving. Next side heading, classification of organic compounds.
So can you once go to the previous page?
Okay. So here onwards, concentrate properly, students. This and all just generally I gave now
Thank you.
for introduction purpose. So here onwards, observe properly. Classification of organic compounds. Acyclic compounds, cyclic compounds. Basic classification I am giving, students. Cyclic compounds. Here, acyclic compounds again classified into saturated. Saturated is nothing but alkanes. And next one is unsaturated hydrocarbons. Unsaturated hydrocarbons. Here, saturated alkanes. Unsaturated alkenes and alkynes. Next, again, cyclic compound classified into two types. Cyclic and cyclic. Highly cyclic, aromatic. Aromatic compounds. So here one by one we will discuss, students. Still classification is there, so much required. One by one anyway we will discuss now. So I'll start with alkanes. Alkanes. Main heading, saturated hydrocarbons. Saturated hydrocarbons. This example is alkanes. Why we call saturated hydrocarbons? These hydrocarbons are called saturated hydrocarbons. Why we call these hydrocarbons as saturated hydrocarbons? Anyone can you tell, students?
I think single bond, something single bond.
C60 is nothing but one polarinum. Anaga C60 is in that C60 C70 call. In that C60 is called Buckminster fullerene. Saturated hydrocarbons means, I told you, students, carbon valency is 4. Carbon valency is 4. If total valency, if it is satisfied with hydrogens and carbons, then that hydrocarbon is called saturated hydrocarbon. Saturated hydrocarbons. carbon contains enough number of carbons and hydrogens, then it is called saturated hydrocarbon. Simply, if you want, carbon and carbon is connecting with the single bond. Carbon and carbon is connecting with the single bond. Then it is called saturated hydrocarbon. It's called saturated hydrocarbon. Saturated hydrocarbon. These are also called paraffins. Paraffins. Para means little. Affins means affinity. These are having little affinity towards chemical reaction. They are having little affinity towards chemical reaction. Why? They all these carbon atoms are having enough number of enough number of hydrogens, means they are having octet configuration around it. No unsaturation. If they are having unsaturation, they readily undergo chemical reactions. Compared to unsaturated hydrocarbons, these are less reactive. So these are also called paraffins. One more thing. What is the general formula of alkane, students? CnH2n plus 2, where n is nothing but number of carbon atoms. Number of carbon atoms. CnH2n plus 2. CnH2n plus 2. So if it contains only one carbon, substitute, students, one carbon means how many hydrogens it needs? 2 into 1 plus 2.
4.
If it contains two carbon atoms, how many hydrogens we need? 2 into 2 plus
6.
2, 6. C2H6. Sorry. C2H6. If it contains 3,
8.
C3H8. So this
Oh,
is
these
what,
are methane, propane, and all.
yes. Methane, ethane. For saturated compounds, AN we will use, students. AN. Propane. This anyway I will give in IUPAC. Okay, students. In saturated hydrocarbon atoms, carbon is connecting with the single bond. General formula of alkanes is CnH2n plus 2. Based on that, we can write the hydrocarbons: methane, ethane, propane, butane, like this. C4H10, butane. How to write this one, see, students? If two carbon atoms are there, look at this. I stop writing, all of you. Here, each carbon is connecting with only one bond. Still, how many bonds it needs? 3 bonds. Like this, we write. If it is propane, how many carbon atoms I have to take? 3 carbon atoms. Here, only one bond is there now. 3 more hydrogens we have to take. Here, this carbon is surrounded by 2 bonds, so only 2 hydrogens if you keep, enough. Here it is surrounded by only 1 bond, 3 hydrogens. So from this, what you observe, students? What did you observe? Terminal carbon atoms are getting 3 hydrogens. Non-terminal carbon atoms are getting 2 hydrogens. If I take this much big chain also, we can arrange easily. What did I say? Terminal carbon atoms will get 3 hydrogens. Non-terminal carbon atoms will get 2 hydrogens. So this one, if we write condensed form, how we will write, student? CH3, 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 CH3. This one, middle one, CH3. Tell me, students. CH3,
CH2,
CH2,
CH3.
CH3. It is not triple bond, it is equal. identical. Here CH3, down I write here, I won't get enough space, which is equal to CH3, CH2, 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 CH2. This is called condensed form. This is called condensed form. Done, students?
Yes, sir.
Students got it? How to write condensed structure? How to write elaborate structure? Extended form and condensed form. Next. Here only I will teach how to write line structure also. See here, CH3, CH3, ethane. So for this line structure is like this. You can write like this, you can horizontally also you can write. If it is propane, how to write, students? Ethane means small line, propane means little big line, isn't it, students? Dhruva? Shall we write like that? Ethane small
I don't think
line, propane little big, butane. Don't do like that. See here, we can't make out like drawing big line, small line. So here, each corner represents one carbon. If it is butane, tell me, students, how to write? You can't tell, no? Like this, one line, like this, one line, like this
one
one.
more. Yeah.
It's very simple. So here, one carbon, 2, 3, 4. Six carbon atoms are there. 1, 2, 3, 4, 4, 5, 6. Like this. Corners you have to create so that we can make out number of carbon. Each corner represents one carbon. 10 Here, one of the hydrogens replaced by one more methyl group. How to represent line form? One methyl group means one line. See, students? Over. Here, this represents one methyl group. Ethyl group means one more line you have to take. This is about line structure. Next side heading, unsaturated hydrocarbons. That first one is alkenes. Alkenes. See, students, in alkenes, carbon contains at least one double bond. Hydrocarbon contains at least one double bond. At least one double bond. Then these are called unsaturated hydrocarbons. Here, general formula of alkenes is CnH2n. CnH2n. I will tell you why these are called unsaturated hydrocarbons. Why these are called unsaturated hydrocarbons. If hydrocarbon has two carbon atoms, how many hydrogens it needs? Yes or no? 2 into 2, number of hydrogens, Cn H2n, C2H4. So hydrogens, number of hydrogens is equal to exactly double of the number of carbon atoms. If it is C3, hydrogens will be H6, C3H6, C4H8, C5H10, like that. Now, here these two carbon atoms I am taking like this. 2 hydrogens I am distributing equally to the 2 hydrogens. I am keeping one bond between these two carbon atoms. Now, each carbon is surrounded by how many bonds, students? Each
3
carbon
bonds.
is surrounded by how many bonds?
3.
Only Dhruva is answering, other students are not responding.
3 bonds.
3 bonds. 1, 2, 3. So, to satisfy the valency, we are giving one extra bond. This is called pi bond. So, if 2 bonds are there, one is sigma, another one is pi bond. Do you know the difference between sigma and pi bond, students?
You told it last year.
Now, do you have any idea about sigma and pi bond?
Yeah, the orbitals, if they are in like, I don't know, like parallel or axial overlapping, something like that.
Yes. Orbitals, if they overlap axially, form sigma bond. If orbitals overlap sideways or lateral overlapping, this is also called lateral overlapping, it results in a pi bond formation. So here, carbon forming, in between 2 carbon atoms, there are 2 bonds. In that, if carbon or anything, if multiple bonds are there, in that only one is sigma bond, rest all are pi bonds. If you imagine there are 100 bonds, in that only one is sigma bond, rest all 99 bonds are pi bonds only. Actually, that is not possible, simply I told. So if 3 bonds are there, in that only one is sigma bond, rest 2 are pi bonds only. 2 are pi bonds. Okay, students. Now, in this compound, we don't have sufficient number of hydrogens. So we kept one extra bond, pi bond, to satisfy the valency. So it is not saturated with number of hydrogens. For 2 hydrogens, actually how many, for 2 carbon atoms, how many hydrogens we need? 6 hydrogens we need. But we have only 4 hydrogens. To satisfy these 2 hydrogens, one extra bond we kept, that is pi bond. So now this carbon atoms are not in saturated condition. Yes, for satisfying the valency, we kept pi bond. These are not satisfied with number of hydrogens provided. So these are called unsaturated hydrocarbons. If they get chance to get hydrogen, by breaking the double bond, they get hydrogens. They are ready to take hydrogens. They are unsaturated. Understood, students, why alkenes are called unsaturated hydrocarbons? They do not have sufficient number of hydrogens to satisfy the valency. Unsaturated hydrocarbons. If they are unsaturated, they are more reactive. That is the reason all unsaturated hydrocarbons are more reactive than saturated hydrocarbons. Because pi bond can break easily. More reactive than unsaturated hydrocarbons. See, students, now suppose propane, if I want to write 3 carbon atoms, I will take And at any one place I'll keep double bond. Any one place I'll keep double bond. Now here carbon connecting with only one bond, right? So 3 hydrogens we have to keep. This idea you have to get. Next, here how many hydrogens we have to give? That depends on number of bonds. Carbon surrounded by how many bonds here? 3 bonds. So still how many it needs? Only 1. Next, here carbon is surrounded by 2 bonds. So 2 hydrogens we have to give. This is the structure of propane. Propane. Understood, students, how to arrange hydrogens? If carbon contains only 1 bond, 3 hydrogens we have to keep. If it contains 2 bonds, 2 hydrogens we have to keep. If it contains 3 bonds, only 1 hydrogen will give.
Sir, can you explain that again?
Which one, Amma? This is how to arrange hydrogens.
Yes, sir, that one.
See, Anaga, first, right number of carbon atoms. Propene means 3 carbon atoms will be there. Prop means 3 carbon atoms. I wrote 3. So I put, sorry, connected with single bond. Single bond is common. Next, here C3H6 according to the general formula will get 6 hydrogens. Otherwise, if you don't know hydrogens also, number of hydrogens also you can arrange. I told you know, alkene means at least 1 double bond should be there. You don't know hydrogen, number of hydrogens, 1 double bond you keep. Any side, this side or this side, you'll get same. Now, this carbon is connecting with only 1 bond. See, student, only 1 bond. 1 bond means it needs 3 more hydrogens because carbon has to connect with how many bonds? 4 bonds. So I took 3 hydrogens because it is connecting with only 1 bond. Next, second carbon, if you see, here 1 bond, here 1 bond, here 1 bond. This side 2, this side 1. Total how many are there? 3 are there. So 1 more hydrogen if you connect, enough. So now terminal carbon is connecting with 2 bonds. So how many bonds it needs? 2 more bonds. For that 2 hydrogens will. Anaga, got it?
Yes, sir. Thank you.
So if we write this one, how get condensed form CH3 CH double bond CH2. If you want to write in line form, this is propane. Just keep double bond. It's very simple. Next, 4 carbon atoms I am taking. 4 carbon atoms. I am keeping double bond here. Anywhere you can keep. For that, no condition. Here, this I'll give the number, students. 1, 2, 3, 4. For first carbon, how many hydrogens I have to keep, students?
2.
For first carbon, how many hydrogens we have to keep?
2 hydrogen.
2 hydrogens. Already 2 bonds are there, no? 2 hydrogens you have to keep. So that balance will be 4. What about the second carbon?
1.
1. Very nice. What about third carbon?
2.
Very good. 2. Fourth one?
3.
3 hydrogens. Very good. Terminal carbon, 3 hydrogens. In this, any doubt, students? You can, if you keep double bond here, that also can be accepted. For this line structure, how to draw? First 4 carbon atoms you draw. 4 over 1, 2, 3, 4. So between first and second carbon, double bond is there. Same way you keep. Do it, students, first. So now you got to know how to arrange number of hydrogens, how to write different alkenes, how to write different alkanes, and what is the line representation of alkanes, alkenes. How to write, how to draw the line representation for alkanes, alkenes. We finished. Shall I go to alkynes?
Sir, could you explain that line
Yes, sir.
representation once?
Say start first. We have to write 4-membered alkane. Afterwards, you just, suppose here numbering I gave like this 1, 2, 3, 4. Just in first compound, double bond is present in between first carbon and second carbon, right? So here also I put double extra bond in between first carbon and second carbon. Only so much.
The lines represent the covalent bonds, right?
Yes,
Got it,
they
sir.
all are covalent bonds only. Organic compounds connecting with covalent, they form covalent bonds only. Shravan, what is your doubt?
But here the hydrogen isn't shown, right?
Hydrogen?
Isn't shown in that line representation.
Hydrogen will be inside. You no need to show. Line structure means hydrogens we are mixing in that only.
Okay, okay, got it, sir.
Here, one dot is there means 3 hydrogens are there.
Okay, sir.
That is the advantage of line structure. To draw structures easily, line structure they introduced.
Sir, only between two carbon atoms double bond will be there, not anywhere else. I mean, there'll not be two double bonds, right?
Can be.
Okay.
Depends on molecular formula, we'll decide. Alkadienes, we'll say. Next one, alkynes. Alkyne means carbon contains at least one triple bond. At least one triple bond. And here, general formula of alkynes is CN H2N minus 2. CN H2N minus 2. CN H2N minus 2. Suppose here 2 carbon atoms are there. How many hydrogens we need, students, according to the general formula?
2 hydrogen.
2 hydrogens. Why? Here 2 into 2 minus 2. You get C2H2. If it is 3, tell me, students.
4.
4 hydrogens. 4.
6.
6. Okay. Now, how to arrange this one? 2 hydrogens are there. Symmetrically, you have to distribute hydrogens to carbon atoms. Now, each carbon is connecting to one bond only, so we have to keep 3 bonds in between the 2 carbon atoms. C2H2. So 2 carbons means eth. Alkynes no I. Ethine. Ethine. This is also called acetylene. C3H4 is there. See, students, any one carbon, any in between any 2 carbon atoms, one triple bond will be there. So here already carbon is connecting with 3 bonds, so only 1 hydrogen. Here already satisfied with all the 4 bonds. So terminal carbon will be. So this is called propyne. Propyne. For this line structure, how to draw, students? Sure. For this line structure, how to draw? Propane, 3 bonds. Propene means 2 bonds I wrote. Propyne means 3 bonds. One if you learn, rest of one will is very easy. Propyne. Suppose here butane I will write. Butane. See. So how to draw this line structure? First butane you draw, then first, two, third, fourth. So first and second carbon atoms contain triple bond. Over. Second and third carbon? No. All saturated hydrocarbons ends with an. Unsaturated ends with ene and ine. If it is double bond, ene. If it is triple bond, ine. Alkyne, alkene, alkane. Ane represents single bond. Ene represents carbon-carbon connecting with double bond. Ine represents carbon-carbon connecting with the triple bond. This is the line structure, general formula, and how to write the structures. Here I explain.
Sir,
Ma.
sir, ethane is C2H2, right?
Yes. C2H2, I wrote no. This is propane. This is butane. If it contains double and triple bonds, that time we won't mention alkene, alkyne. We'll give combine that IU base names. I'll give that time will come to. That time we'll tell simply it is unsaturated hydrocarbon. Unsaturated hydrocarbon. Only so much. Cyclic compounds. Any doubt in alkanes, alkenes, alkynes?
No, sir.
No, sir.
Only Chinmay and
No,
Dhruva
sir.
understood. Shravan, if I explain this one, you will come to know what is the difference between cyclic and acyclic. Acyclic means open chain. Cyclic means closed rings they'll form. See here, cyclic compounds. Here minimum 3 carbon atoms we need. They form closed structure. Here each carbon atom is connecting with the 2 bonds. So 2 hydrogens if we give each carbon enough. Check once. This is called cyclic compound. No cyclo prefix we'll use. Total 3 carbon atoms are there. No cyclopropane. There is no double bond. So N we will write. Anyone, can you tell this one, students? Name of this one, cyclopropane. I said. What about this one?
Cyclobutane.
Very nice. Cyclobutane. If ring contains 5 carbon atoms,
Cyclopentane.
cyclopentane. Stay. Cyclobutane. Cyclopentane. These are line structure. How to draw for this? Nothing is there.
Triangle.
Triangle. For this, square.
Where?
For this, pentagon. Cyclic compounds. These are all called alicyclic compounds. Alicyclic compound. Copy it, students. Please, if you have doubts, ask me, students. Learn properly, otherwise in first year, second year, you will find difficult.
Sir, what are its properties?
Which one?
Alicyclic
Alicyclic?
properties, like it's different in shape, right? So I asked.
Generally, cyclic compounds, cyclic structures are stable, but in this case, they are not much stable. Only leaving cyclohexane, rest all are less stable. The reason what you know, actually is cyclopropane. In our maths, triangle is there, no? What is the angle between the two planes, students? Two lines.
I mean, if it's equilateral, then 60 degrees.
Equilateral only you can.
60 degrees.
That I can't apply. Actually, here 3 carbon atoms means we have to make it 360. We have to make it equal parts 120, 120. But here bond angle is 60 degrees only. If it is 120, they are comfortable. Atoms will not get much repulsions. Here, instead of 120, in a triangular plane, this one in cyclic form, they are getting 60 degrees. Carbon atom in between the two bonds, bond angle is 60 degrees. That from 120 degrees or 109 degrees. Actually, it is not 120 also. 109 degrees. Since we consider this carbon atom is sp3 hybridized. Papa, you don't know what is sp3 hybridization. I will tell you one simple thing that only follow. If carbon is connecting with single bond, then it is undergoing sp3 hybridization. We will tell simply. You just consider carbon atom, if it is connecting with only single bonds, then it is undergoing sp3 hybridization. sp3 hybridization carbon groups bond angle must be 109 degrees, but here it is 60 degrees only. So lot of change is there, lot of difference is there, 109 to 60. So that is called ring strain. Ring strain. It is deviating from the original bond angle. If it is deviating from the original bond angle, it loses its stability. How much it deviates, so much it loses stability. That is called bond angle strain. That was given by various scientists. So these cyclopropane, cyclobutane, these are all unstable because of more ring strain. This is one type of this is one class of hydrocarbon list. Hydrocarbons contain more number of carbon atoms called crude oil. These properties and all we will explain later. First classification let me do. Otherwise we'll get confusion simply. Now you asked one property, for that I explained wear strain. Actually it will come after 4 or 5 topics. Okay. So sometimes it may end up topic. Upcoming topic, if I explain now, you will get more confusion. First, let me finish classification, then we'll go for properties. The properties are there, I will discuss. So, cyclic compounds. Next one, aromatic compound. In cyclic compounds, there are 2 types, alicyclic and another one is aromatic compounds. Aromatic hydrocarbons. Aromatic carbon, hydrocarbon. Best example is benzene. Alternative double bonds are there. So line structure, if we write double bond here, double bond here, double bond here. This is called aromatic benzene. For this benzene ring, one more benzene ring if we attach, it is called naphthalene.
That naphthalene balls one.
Yes, same. And one more ring if I attach, anthracene. 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 Upon benzene ring, CH3 group, if I keep, this is toluene. This is called toluene. Just few examples here actually. These aromatic hydrocarbons, there are two types. Homocyclic. This one is homocyclic. Homocyclic means in these rings only carbon atoms and hydrogens are there. These rings are formed by only carbon and hydrogen atoms. Another type is there, heterocyclic. Heterocyclic. Heterocyclic means other than carbon and hydrogen, nitrogen or oxygen or sulfur will be present in the ring formation. Those are called hetero, means different. Here a different, at least one different group will be there rather than carbon and hydrogen. This is name of this compound is pyrrole. Pyrrole. You no need to by heart all these things, students. Just keep this thing. Number of times you just revise, automatically you can remember. This is called
What's that two dots? Is that Lewis structure?
Lewis structure, lone pair of electrons.
Okay.
Furan. Have you heard pyridine, students?
Yes, sir.
This is
And,
pyridine.
and also furan also. Furan ring.
Furan. These are heterocyclic compounds. Aromatic, homocyclic, aromatic, heteros or homocyclic. A classification, B classification. So this much is enough for classification.
Sir,
Yes.
this homocyclic and heterocyclic come under aromatic compounds.
Both are come under aromatic. Aromatic compounds are two types. That homocyclic aromatic, heterocyclic aromatic. Now, see students, CH3, CH3. This is the first carbon, second carbon, third carbon. You can give numbering from reverse direction also. Same it is. In this case, see here, second carbon connecting with methyl group. On second carbon, methyl group is there. If second carbon contains methyl group, then it is called iso. Prefix iso will use. Some compound, only 3-4 compounds are there. we'll get some different names that I will give. These are familiar with the trivial names. Iso. How many carbon atoms are there, students, total in this compound?
4.
4 carbon atoms are there. 4 means bute.
Isobutane.
Isobutane. Can you tell students what is the name of this compound?
Isopentane.
Very nice. Isopentane. Understood, students? Where we use iso, if second carbon connecting with methyl group, CH3 group is called methyl group. This one also I will give. See, students, this is methane. CH4 is called methane. From methane, if you remove one hydrogen, it is called methyl. Methyl. From ethane, if you remove one hydrogen, it is ethyl. Simply I can write like this: hydrocarbon minus hydrogen, alkane minus hydrogen gives alkyl. Understood, students? Alkane minus hydrogen gives alkyl. Methane contains 4 hydrogens. If you remove one hydrogen, it is called methyl. So total number of hydrogens minus 1 you have to do. Students got it?
Yes, sir.
I'll write here C3H8. What is the propyl formula?
C3H7.
H7.
C3H7. Very nice. Next, one more thing I'll give. CH3, CH3. Observe properly and tell me. CH2. What is the name of this compound group?
Isopentane.
Iso.
Pentane.
How many carbon atoms are there, Chinmay?
4.
4 carbon atoms are there. No, then isopentane, how can you say? Above one, you just observe this one, this one, this one, this one, this one. What is the name of this compound, students?
Isobutane.
Isobutane. From isobutane to this one, what is the difference?
Isobutane.
Very nice. Isobutyl. From 3 hydrogens, I remove 1 hydrogen. So this group is called isobutyl. Isobutyl. Alkane minus hydrogen gives alkyl. Alkane minus hydrogen gives alkyl. Students understood where we use or where we'll use iso? Next. What is the name of this compound? Means you don't know, I will tell you. Simply. One carbon is connecting with 4 other carbon atoms. Yes or no, students? The middle carbon is connecting with 4 other carbon atoms. So, if it is connecting with 4 other carbon atoms directly, we will use neo. Afterwards, 1, 2, 3, 4, 5 carbon atoms are there, no? Neopentane. Neopentane. Shall we go to IUPAC names?
Yes.
Before going to IUPAC, one more I want to give. I want 1 minute, students. Stop writing, all of you. Here, I'll give the numbers 1, 2, 3, 4. First carbon is connecting with how many carbon atoms, students?
1.
How many carbon atoms?
1.
Directly, so how many carbon atoms? Only 1. So it is called primary carbon. First carbon is called primary carbon. What about second one?
2 carbon.
Huh?
Carbon atom.
Jyoti. Second carbon is connecting with how many other carbon atoms?
2 carbon atoms.
2 carbon atoms. So it is second degree carbon or secondary carbon. Very good. What about third one, students?
2 carbon.
Also 2.
2 carbon atoms only. So I'll remove this. So this one is primary carbon. Second and third both are secondary carbons. What about fourth one, students?
Primary carbon.
Primary carbon. Understood how to find out primary carbon, secondary carbon? Now, in this compound, I'll give one more compound. You only tell me. How many primary carbon atoms are there? You tell me.
2.
Very good. This one is primary carbon, and one is primary carbon. What about this one, students?
Tertiary carbon.
Very good. Tertiary carbon. Since this carbon is connected with 3 other carbon atoms. What about this one?
Secondary carbon.
So this compound contains 2 primary, 1 secondary, and 1 tertiary. If it is connecting with 4 other carbon atoms, quaternary carbon. If it is connecting.
So what about the other carbon?
Emma?
The carbon
Which is above, right?
yes.
Primary only.
Yeah.
Oh, one more is there, no?
3.
Yeah. 3 primary, 1 secondary, 1 tertiary. Third degree. Understood, students, how to find out primary, secondary, tertiary, quaternary? Sometimes directly they are asking. One compound they'll give number of primary, secondary, tertiary carbon atoms. Okay, now you are the experts. Find out primary, secondary, tertiary, and quaternary also. I'm already 5. Students, 5, no? 10 minutes break you take. Again, wait. Okay. Next, now you keep side heading, students. IUPAC. What is the full form of IUPAC, students?
International Union of Physical and Applied Chemistry.
What physical?
Pure and applied.
Yeah, pure.
Physical, mental, you are telling? Pure and applied IUPAC. So here, carbon can form billions of compounds. So to remember all the names, means remembering all the names, it's very difficult. So they introduced one system, that is International Union of Pure and Applied Chemistry. So this system has given some rules. They have given some rules. According to the rules, we'll name the compound ourselves. Okay. So here, before going to IUPAC systems, I'll explain few terms here. One is root word. Root word. Root word indicates number of carbon atoms present in the chain. Right, Nana? Number of carbon atoms. So here, number of carbon atoms. If one is there, root word is RW. I am keeping, students. Mith. Two carbon atoms are there. Ith. Three are there. Pro. Four are there. But. Five. Pent. Six. Hex. Seven. Hept. 8 oct, 9 non, 10 dec, 11 undec, 12 dodec. Like this, tridec and all. Not required. So one up to 10 we will write. We'll get many. This is about root word. So base, if two carbon atoms are there, prop will use. If three carbon atoms are there, prop. Four carbon atoms, but, pent. Based on the number of carbon atoms, we will use the root word, or root word indicates number of carbon atoms. If they give root word, we can find out number of carbon atoms. If they give number of carbon atoms, we can give the root word. Next, primary suffix. Next side heading is primary suffix. Listen carefully, students. Primary suffix. Earlier I introduced alkane, alkene, alkyne. We know number of carbon, eth, prop, but, pent will write. Whether we have to give ane, ene, or ine. Or how do we come to know whether double bond is present or triple bond is present or only single bonds are there among the carbon atoms? By using primary suffix. If all carbon atoms connecting with a single bond, primary suffix is ane. Primary suffix is ane. If at least one double bond is present, ene. At least one triple bond is present, ine. So this primary suffix indicates double, triple, or single bonds. Or simply you can write saturation or unsaturation. Primary suffix indicates Saturation or unsaturation. Unsaturation. Saturation or unsaturation. For saturated compounds, what we use, students? In. Unsaturated. If it is double bond, in. If it is triple bond, primary suffix is I. Understood, students? What is the importance of primary suffix? You'll get to know whether it is alkane or alkene or alkyne. Next side heading, secondary suffix. Secondary suffix. Secondary suffix indicates nature of the functional group. Nature of the functional group. Nature of the functional group. Suppose here some important functional groups I give. OH group is there. Suffix is, secondary suffix is ol. Aldehyde group is there. All. Keto group is there. On. Carboxylic group is there. Oic acid. Oic acid. Acyl chloride. OL. COCl group is there. OL chloride. NH2 group is there. Amine we call. Secondary suffix is amine. Like this. X is there. Halo. Generally, it won't act as a functional group. They always substitute only. Halo. Yes, these are the important functional group. CN group is there. Nitrile. Nitrile. People, now you join. Now only you join. Okay. Functional group you want. Okay. Right. Side heading functional group you keep. Functional group is nothing but the heteroatomic group. Otherwise, the group which is functional group proper definition. So it is OH or CHO or some other group will be joined to the hydrocarbon group, no students. That will decide the chemical property of the compound. That will decide the chemical property of the compound. Right now, group which gives characteristic properties to the hydrocarbon chain. Group which gives characteristic properties to the hydrocarbon or alkyl chain also you can write. Alkyl chain also you can write. Example, if you see CH3 OH, CH3 CH2 OH, CH3 CH2 CH2 OH. In all the case, if it reacts with sodium, only this hydrogen will be replaced by sodium. Here also same thing. Here also same thing. If it reacts with sodium, other part will not get disturbed. So irrespective
So does
of
it have to be called a functional group only if it is there in hydrocarbon?
sorry.
Does it have to be called a functional group only if it's there in hydrocarbons?
If only hydrocarbon is there, we won't call. They won't.
No. Like if that OH is there in any other group and it decides its chemical property, then can it be called a functional group?
Yes. That chemical property decided by that particular group only. Only that group involves in chemical reactions. Shravan, got it?
No, sir. I asked if that OH is there in any other chemical compound, and then there also it decides its chemical property. Can it be called a functional group?
You are asking other than hydrocarbon, if we keep OH group to any other group. Can you give one example like that?
Like any bases.
Any?
Bases like calcium hydroxide.
No. That only when it is connected to the hydrocarbon.
Proteins.
Only when it is connected to the hydrocarbon, we call it is a functional group. It does some function here.
Like that COOH is binded to CH3, right, in acetic acid.
COOH together, it is one functional group, right? In that you can't separate CO and OH. COOH together one functional group. Carboxylic acid.
No, I said COOH is binded to CH3, right, in acetic acid.
Yes. It is a functional group. COOH is functional group, not OH.
Oh, even CH3 is a functional group, right?
CH3 is not functional group. COOH is functional group.
Then what is methyl, sir?
Methyl is just hydrocarbon. Methyl is hydrocarbon. Alkyl groups always act as substituents only. They won't act as functional groups. Heteroatomic groups which are connecting to hydrocarbon, it's called functional group. It's called functional group. Heteroatomic means other than carbon and hydrogen combination. If you get other atoms, then it is called functional group. CHO is there. With carbon, oxygen is there. Methyl group is not a functional group. See here, this is the functional group. Methyl is hydrocarbon. OH is the functional group. Ethyl is the hydrocarbon. Here, propyl group is hydrocarbon. OH is functional group. Shravan,
Yes, sir.
suppose if some Dhruva asks, no, if methyl is the functional group, from first reaction to second, third reaction, we should get different products, and the chemical reactivity should be differ. It is not changing. Here, methyl group if it involves, if ethyl group involves, and here propyl group if it involves, no, we will get different products. Here, only OH is involving in chemical reaction. OH is deciding the reaction, direction of the reaction, not number of carbon atoms. See here, first case only one carbon is there, second case 2 carbon atoms are there, third case 3 carbon atoms are there. Irrespective of number of carbon atoms, we are here chemical reactivity. Sodium is reacting in particular area only. OH group is deciding the direction of the product or deciding the product. So this type of groups are called functional groups, which is involving in the action, chemical action, that is called functional group. It is doing some function, so it is called functional group. Here, number of carbon atoms we increased. Because of that, there is no change in the reaction. Dhruva, got it?
Yes, sir.
Okay, functional group which decides the properties of alkyl chain. Decides the property of alkyl chain. Okay. Next one. Secondary suffix over. Side heading. Prefix, students. Prefix. Prefix means so here which is the functional group, students, tell me,
OH.
all of you.
OH.
OH is the functional group. OH is the functional group. Now in this, one of the hydrogens I am replacing with bromine. We got one functional group, and now this one is substituent. This one is substituent. That one of the hydrogen replaced by bromine. So here this is called prefix. For this, what we have to use, from functional group we will use the number 2-bromo. Prefix we have to write first. In which position bromine is there? Second position. 2-bromo. How many carbon atoms are there? 3. So root word is propane. Propane. Functional group is OH. So suffix we have to write propanol. Propanol. Understood? So prefix means substituents present in the chain. Prefix represents substituents present in the So here bromo is the prefix, prop is the root word, ol is the suffix. So to write one IUPAC name, what is the order, students? Prefix, if it is there, plus root word, then suffix. Suffix. Here one more is there, an. This is primary suffix. This is secondary suffix. Secondary suffix. Primary suffix is an. So what is the order, students? Prefix plus. So while writing the names, you automatically will get to know root word, primary suffix plus secondary suffix. Prefix indicates substituent. Root word indicates number of carbon atoms. Primary suffix indicates an or in or in. Secondary suffix indicates functional group. Here an, in, or I. Here root word, number of carbon atoms. It like this. Prefix, substituent. These things, this order, if you know, you can write the names. Now you got to know the order of the priority, which we have to write first, which we have to write next. So once again, I repeat, students, stop writing all of you. First one, root word I told. Root word indicates number of carbon atoms. Suffix indicates primary. Suffix indicates saturation or unsaturation. Prefix indicates substituent. Secondary suffix indicates functional group present in the chain. These things. Shall we start the name, students? After writing 5-6 compounds, you'll come to know how to write the names. So alkanes, I'm going to start first. What is the name of this compound, students?
Butane.
Very good. How many carbon atoms are there? 4. But. All are single bonds only. Butane. All carbon atoms are connected with single bond. Butane. So in case of branched chains, what to do?
Isobutane.
No, that is common name. IUPAC name is different. Here, see, students, this is the normal chain. For this one, substituent is there. Substituent is there. One of the hydrogens replaced by methyl group. In this case, you have to give the numbers. Numbers where to give? From which side we have to give? Every time we have to give the number in such a way that the substituent should get lowest number. This is called lowest locant rule. Lowest locant rule. For the substituent, we have to give the lowest number in such a way that we have to decide the numbering. See, students, I'll give with the different colors numbers. From right to left, if I give 1, 2, 3, 4. From left to right, if I give 1, 2, 3, 4. Which is the preferred direction, students? Left to right or right to left? Substituent should get lowest number.
Left to right.
Everyone has to tell.
Yes.
Left to right or right to left?
Left to right.
Left to right. Why? Here substituent in this direction, substituent is getting second number. But in this direction, substituent is getting highest number, third number. So preferred direction is left to right. So what is the, now this is the prefix. Second position, methyl group is there. 2, just give icon between numerical, this number and prefix. 2 methyl. How many carbon atoms are there, students? 4. Butane. 2 methyl butane. So if you give numbering from this side, 3 methyl butane you will get. This is not correct because substituent is getting highest number. It shouldn't get highest number. Understood, student, this rule?
Yes.
The branches are there, no? Those branches should get lowest number. So first you check from left to right, you give the numbers. Right to left you give. Which direction substituent is getting lowest number, that is the preferred direction. Anyone, can you tell the name of this compound, students?
3-methyl hexane.
3-methyl hexane. Chinmay, correct answer. Which side, from which direction you have to give number, students? Numbering.
The same.
Any side you can give. See, students, from this side, if you give 1, 2, 3, 4, 5, hexane you said. Chinmay. Pentane. You cheated me. 3-methyl pentane. Very good, Amma. No problem. Number of carbon atoms we got confused. Any side you give numbering, or substituent will get same number. In that case, you can give numbering from any direction. So 3-methyl pentane. 3-methyl pentane. From which side you have to give numbering? Left to right or right to left?
Yes, sir. In the previous example, why isn't the upper carbon considered?
3-methyl already we gave, no?
No, sir. There are 6 carbons. Then how is it
That's what
pentane?
is 3-methyl I said now.
Substituent.
Methyl I said now. In that one carbon covered, right?
Oh, yes, sir.
3-methyl,
Yes.
that's separated. That is a guest now. We can't consider in family number.
Yes.
Left to right or right to left, students?
Left to right.
Right.
Left to right. Why? If you give numbering from this side, 1, 2, 3, 4, 5 will get. Not we. Substituent will get fifth number, fifth position. If we give number from this side, 1, 2, 3, 4, 5, 6, 7. Tell me the name of this compound, students.
3-methyl
Methyl heptane.
3-methyl heptane.
Why is it methyl?
Huh?
Why is it methyl? Methyl.
Methyl.
Yeah, so why it is like that?
This is methyl. CH4 is methane. Beginning I said no in the first one and a half that session I told no. Alkane minus hydrogen gives alkyl. Methane minus hydrogen gives methyl. Ethane minus hydrogen gives ethyl.
Yes, sir, got it.
Got it, no? Tell me, students. Which substituent is present, students?
Ethyl.
Ethyl. Which position it is?
Third position, yeah.
Third position. Very good. So tell me, students, together. 3-ethyl
3-ethyl hexane.
hexane. How many carbon atoms are there? 6 hexane. Aste. Now, I'm going to create one more confusion among you people. Try to get confusion.
Nice try.
Sorry.
No, it's not over.
Not over, not over. Not over. From which side I have to give numbering? From left to right or right to left? Here, no confusion. You can tell directly. Shravan, correct answer. Left to right only because 1, 2, 3, 4, 5, 6, 7. If you give numbering from this side, 1, 2, 3 you are getting for this substituent. Okay. So this side only are considered. But Emma, this substituent name is methyl. Observe properly here. One more rule I am going to cover. This substituent name is. These are the substituents. Yes or no? Not speaking. Two different substituents are there in different locations. One name is methyl, another one is ethyl. One is methyl, another one is ethyl. In that case, irrespective of numbers, alphabetical order you arrange. Two prefixes are there, no? One is methyl, another one is ethyl. So first in alphabets, E comes first, right? 5-ethyl. Next, 2-methyl. Numbering will give as it is, but while writing the names according to alphabets, we'll arrange substituents. 3-methyl, 2-methyl, heptane. Right now. Arrangement of substituent follows alphabetical order. Numbering will give as it is, but while arranging the prefixes, alphabetical order will follow. Any doubts, students, in this?
Sir, why can't we do it from right to left?
Why can't we?
Do the numbering from right to left.
Right to left, if you give, your substituent is getting third position, no? First substituent. Here,
Yes, sir.
this side, if you give, second, it is getting substituent.
Yes.
Next, one more thing I will do. You send another. Samarth.
If we had done the numbering from right to left, the ethyl group would have been on third, right? So why is it illegitimate?
For that, one more technique I give. You just follow. Here, substituents positions, you tell me, students, from left to right. Left to right, if you take substituents positions 2 and 5. Yes or no? Dr. Shravan, tell me yes or no?
Yes.
7. Next, from right to left, if you give numbering,
It would be 9.
1, 2, 3, 4, 5, 6, 7. Just tell me right to left, which one are positions? Third one and sixth one. This sum should be lowest. Lowest sum rule. Also, you can say. Shravan, got it?
Yes.
So this is the preferred one. This is not. Understood, students? Still, if you have any confusion, use this method. Some of the locants, which direction you are getting less, that. No, that's what I said. 2 methyl, 5 ethyl, you can't take. In alphabetical order, you have to arrange, I said, Samarth. Okay. Next, one more different example it is, because different rule I am going to cover. Now, I am taking methyl group in third position from this side. Here, ethyl group I am taking third position. Which side we have to give? If you give numbering from this side, methyl will get third number. If you give numbering from this side, ethyl group will get third number. Which we have to select? Which direction? Right to left or left to right? Remember your English, ma'am. You can answer.
Left to right.
Why?
Sorry, right to left.
Again, you learned English.
You can give it anyhow because however you have to arrange it.
No, how can you say anyhow? Both are not same, Tanmay.
From right to left because you will get smaller number.
That's what I said. You remember your English teacher. Right to left, if you remember your English teacher, because
Yeah.
different substituents from same positions means alphabetical order we follow. E comes first. 1, 2, 3, 4, 5, 6, 7. Tell me, students, name of this compound. I gave the number. You know the substituent names.
3 ethyl, 5 methyl, heptane.
3 ethyl, Very nice. Line first. Next one. Should I give one more example with different many substituents?
Yes, sir.
Are you ready, students? Take little challenges, little risk if you take. Here, this little risk if you take, there you will feel comfortable.
You can add functional groups also.
No, that I is there. No, now I am giving only alkenes. So next one, naming of the compounds with functional groups. Separately, I will teach functional group wise. So don't worry. IUPAC 50 to 60% I will cover here only. Very simple compound I am giving. Wait, students, I will give some rules. Yes. First, you have to select the parent chain. Selection of parent chain. Wait, students, please. I'll give time. If you understand this one, many compounds you can do. Some students are finding network problem. Tanmay, wait, you're writing like news reporter continuously. Wait. Selection of parent chain. Shravan, if I tell for Tanmay, it is not only for Tanmay, for everyone those who are writing. I can call only some names, few names. See here, you have to select the different chains are there. This is one chain. This is one chain. This is one chain. This is one chain. And if you want one more is there. This is one chain. In this, which you have to consider parent chain. The chain which contain more number of carbon atoms. Parent chain must contain more number of carbon atoms. Now your work started. Just count. Which is the parent chain? Just tell me the color of the line beside.
Purple chain.
Sorry?
Purple chain.
Green, huh?
Purple, sir.
Purple. Purple, if you consider. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon atoms we got in this direction.
Green chain only 9.
Huh?
In green chain only 9 is there.
Okay, that's
So
1, 2, 3, 4, 5, 6, 7, 8, 9. This side, how much? We'll write numbers. Beginning now. Next, this side and all, no need to count. We'll get very less number. Okay. Competitors only 2. Okay. That we will select one. Which is the correct one, students? 10-member ring we have to select or 9-member ring we have to select?
That
10-member, that is the parent chain. Okay, so I will erase all these things. So numbering you have to give. Tell me students, from which side I have to give number? Lowest sum rule. Left to right or right to left. If I give, I have to give numbering from this side. 1. Color I will change, you won't get any confusion. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is one direction. Another one, green I'll give. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I miss anything, you please let me know, students. So, okay. Green substituents you count, students. Green direction where and all we got? Fourth position 2 times we got. 4 plus 4. 2 times 2 substituents are there in one position means 2 times you have to write. Understood? 2 substituents are there means 2 times you have to write the position. Next. 5. No, not 5. In which position? 6th position, right? One ethyl group is there. And 7th position ethyl group is there. This is green color direction. Next, go for pink. 1, 2, 3, 4th position plus 5th position. Next, 7 plus 7. Anything else, students? Only so much, right? Now count this one. 4 plus 4, 8, 14, 21. Here 9 plus 14, 23. Which side is preferred one, students? Green or pink?
Green.
Green.
Green. Understood? So pink will cut it. Tell me the name of this compound, students. This group is ethyl group. This is one substituent. Just round up like this. This one is ethyl. This one is ethyl. Methyl. Emma.
4 methyl.
4.
4 ethyl. 7 ethyl.
Okay. Don't write name. She is trying.
4 ethyl. 7 ethyl.
Okay.
Ethyl. 6 methyl. Decane.
Okay. So same substituents are there. What she told, some correction is there. Arrangement is proper, everything is proper, but this one ethyl group, this one also ethyl group only, no? That time you can write at a time 4, 7 diethyl. Same substituent, if it repeats, numerical prefix di. If it repeat 2 times, tri. If it is repeated 3 times. Understood, students? 4th position ethyl group only. 7th position also ethyl group only. So 4, 7 diethyl. Next one, can you tell, students? Next substituents are there. No? Can you tell? The same process. Ethyl we wrote. One more substituent is there, no? Which one?
Dimethyl.
Very good. 4, 6 dimethyl decane. Nothing is there, just we followed our rules. It is a big compound, but nothing is there to write. Once if you, now you are learning the names and writing big complex names, no? So you may find bit difficult in the beginning, but you practice like this continuously, 10, 20 compounds like this, if you do, you'll become perfect. Students understood this compound clearly? So here, 3 rules I covered. What are the rules? One is selection of parent chain. How to select parent chain, students? The chain which contain more number of carbon atoms. That is the first quality. And second rule, what did I say? If same substituent repeats more than one time, based on the repetition, based on how many times it repeated, we will use di for 2 times repetition, tri for 3 times repetition, 4 for 4, tetra for 4 times repetition. More than that won't be there. Okay, repetitions and locations also you have to mention, students. Where it is appeared, you have to write. See here, ethyls are presented, located at 4th position, at the same time 7th position. So 4,7 diethyl. Suppose in the 4th position only, ethyl group, 2 hydrogens replaced by ethyl group. That time also you have to write 4,4 diethyl. Hope you understood what I said. Instead of methyl, this one ethyl group is there. In that case also, 4 you have to repeat 2 times. 4,4 diethyl. Okay. Once 4 dimethyl shouldn't write. Di you are writing means 2 numbers should be there in front of di. Otherwise, this name will be di. Don't kill the compound. Okay. And different substituents in the same locations located. From left, one substituent is getting which compound, Shravan?
This one also.
Of course. My lecturer, one cycle, bicycle is there. Now bicycle structure he driven. He asked me to put give the name. And one time he had given like this.
Nazi symbol.
As the symbol. Is this compound? See, this side. 1 minute, I did a mistake. Like this, it has to come, no? I'll name this compound. Afterwards, you tell, oh, only this much. 1, 2, 3, 4 carbon atoms are there. 1, 2, 3, 4, 5. Now, this group is ethyl group. This group is ethyl group. Stay. No, stay. So now name this compound. Now you can name this compound. Chinmay.
3,3 diethyl pentane.
Only so much. What you did, that one only difficult one compared to this. But by seeing this, more. This one is ethyl. This one also ethyl. Third position, two ethyl groups located. No, 3, diethyl pentane. First when I like expression. Now here also same thing. 1, 2, 3, 4, 5. Is only single line. No, one methyl group. Name this compound, students. Chinmay, please don't give the name. Other students.
3-methyl
Ah,
pentane.
first say 3-methyl pentane. Is it difficult? No.
Sir, how will we get to know if it is ethyl or methyl?
Straight line means how much big it is also one carbon only. See, you ask no, Anaga, look at this side. This ethyl. Because corner means N1 carbon, corner 1 carbon. Understood, students? You are not giving response.
Yes, sir.
Straight line, how much big from Bangalore to Bangalore? If I draw also, it is 1 carbon only. What is this, students? Chair, no? Chair. Yes. Table you take, chair you take, dining table you take. Give the names. It's for fun. Okay. Next one. Naming of the compounds with functional groups. Functional groups. So I'll start with the alkyl halides. Alkyl halides. Look at side, students. Stop writing, all of you. Shall I give line structures only? Because in competitive examinations and all, they'll give line structures only. If now onwards, if you do, you'll be very familiar with these structures. Now you are able to understand line structures also. See, students, 1, 2, 3, 4 carbon atoms only. For fourth carbon, chlorine is attached. But this side we can't give numbering. From this side only we have to. Substituent should get lowest number. So if you want to give this name, name for this compound, triple bonds you want, I'll give. Note I will put anyway. I put heading in between. if you want to give the number also, students, 1, 2, 3, 4. We shouldn't give numbering from left to right because substituent will get fourth number. If you give it from this side, wherever the substituent is there, from that side you give 1 chlorobutane. This you tell me, students. Tell me name of this compound. Generally for halogen contain alkanes, what we call common IUPAC name, haloalkanes. If it is chlorine, chloro. If it is bromine, bromo. If it is iodine, iodo. Alkane, based on the number of carbon atoms, we will give root word. Tell me, students.
3-chloropentane.
3-chloro, very good. Anaga, Chinmay, and some students sent names. So I can check properly. Advit, Samarth. Very good. 3-chloro. 1, 2, 3. 3-chloro. How many carbon atoms are there, student? 4, 5, 6.
Chlorohexane.
Easy, students. Nothing is there. Which side I have to give numbers, students? Tell me. Left to right or right to left? Reason also I want.
Left to right.
Why?
Because alphabetical order.
Very good.
comes
Ajit, correct answer. Anaga, correct answer. Left to right. Because B comes first. So bromine from left to right, if you give numbering, bromine is getting lowest number. From right to left, if you give, chlorine is getting same number. In that case, alphabetical order is the preferred one. 1, 2, 3, 4, 5. Tell me the name of this compound, students. Very good. 2-bromo, 4-chloropentane. Between the number and the name, sorry, 2-bromo, this hyphen should be there. 2-bromo, 4-chloropentane. Could you give the number name of this compound, students? Chinmay, correct answer. I told Samarth. Dibromo you wrote, but only one locale you wrote. Yes, now it is correct. See, some students numbers they are giving from that direction. Substituent should get lowest number, I say. And same position if it is there also, 2, 2 dibromo you have to write. that location 2 times you have to mention dibromo pentane. Pentane.